Good evening and welcome once again to my YouTube channel, Maths with Ease by Mr. Kamotho. And I want to now introduce to you a new topic, shape and space 10. And in this topic, we shall actually be generally talking about trigonometry and trigonometric graphs. Of course, we know trigonometry is the specific ratios of angles depending on where the angle is and of course the size. It is a branch of mathematics that broadly deals with angles, and in this one we are just going to get ourselves introduced to it. And I know by now we know the primary trigonometric ratios, and these are sine, cosine and tangent. And we also know the acronym SOHCAHTOA. SOHCAHTOA means the sine of an angle is given by the opposite of a hypotenuse. The cosine of an angle is given by adjacent of a hypotenuse. And the tangent of an angle is given by opposite of adjacent. Now, we should also know that if we move from 0 degrees, this direction, which is anti-clockwise, is called the positive direction, and this direction is called the negative direction. And as such, this is the first quadrant because we are starting our journey here, moving this way. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Quadrant is quarter of a circle when we have a whole circle divided into 4 parts, generally by the x-axis and the y-axis, this being the origin. The horizontal movement is the x displacement, and the vertical movement is the y displacement. If we happen to have a circle whose radius is 1 unit, just like we can see here, from the origin to the right we have x displacement, and upwards we have the y displacement. And I would want us now to talk about trigonometric ratios in the first quadrant. And I want to start with the sine of the angle theta. This is the angle theta. So the sine of the angle theta, as it were, is actually opposite of a hypotenuse. And considering where theta is, y becomes the opposite side of the angle. Hypotenuse remains 1. And therefore, if we say opposite of a hypotenuse, we are simply saying y over 1. And in this case, y is equals to the sine of theta. If we want to talk about the cosine of theta, which according to SOHCAHTOA is adjacent of a hypotenuse, depending on the position of the angle theta, this side is the adjacent. Remember, we have to use the SOHCAHTOA, we have to have a right angle triangle. So the adjacent is x, hypotenuse remains 1. So the cosine is x over 1, whereby we know x is equals to the cosine of theta. And that is why the coordinates of point P, which is as far as x displacement is concerned, and x is cos theta, and y displacement here, they are meeting here, and y displacement is sine theta. So the coordinates of P is cos theta, sine theta. Now we can talk about the tangent of the angle theta, which is opposite over adjacent, y over x, and that is it, because you can see the opposite is y, adjacent is just x. That is as far as quadrant 1 is concerned. All of them are positive. All of them are positive. let us go to quadrant 2, and assuming we have the same kind of line here and the right angle triangle here, and this is theta. In quadrant 2, using this triangle now we have created, from here to the left, this is negative displacement, and x becomes now negative, and y continues to be positive. This is 1. Please note, from this origin to the left, along the x-axis, we are going towards the negative side of the x. So therefore, if we would now want to let's say tan theta is y over x. If we now want to talk about the theta, and once we call the theta here, the moment we consider the angle between the horizontal x-axis and the line of angle, we are also considering the angle from here all the way to this particular point, and I will explain that later. So the sine of angle theta is now the opposite of a hypotenuse, which is y over 1, again, is actually equals to y. The cosine of angle theta is adjacent of a hypotenuse, which is, now you can see this is negative x, negative x over 1, which is negative x. And the tangent of the angle theta in this particular quadrant is opposite over adjacent, which is y over negative x, and it is as simple as that. And in this one, you can already see that only sine is positive in that quadrant. The cosine and the tangent are negative. If we may want to go to the third quadrant and do the same, we are going to have now, this is angle theta there, this remains minus x, and now because the y displacement, you're moving from this particular point going down, this now becomes negative y, and the hypotenuse remain the same as 1. And as such, the sine of angle theta now in this quadrant, opposite of a hypotenuse, which is, the opposite is now negative y over 1, which is negative y. The cosine of theta, which is adjacent of a hypotenuse, and the adjacent is negative x, hypotenuse is 1. And the tangent of theta is opposite over adjacent, which is which can be seen to be negative y over negative x, and this gives us y over x. You can already see now in that quadrant, which is the third quadrant, the sine is negative, the cosine is negative, the tan is positive. And if we may be interested, we will say in this quadrant, all trigonometric ratios are positive. In the second quadrant, we have seen only sine here is positive. Only sine here is positive. So sine is positive. In the third quadrant, we have seen only the tan is positive. Tan is positive. And let us see what happens now in the fourth quadrant. In the fourth quadrant, we continue to create the same right angle triangle, and our theta there, you can see from here to this side is positive, and this is negative y. This remains 1. In the same way, the sine of angle theta, which is opposite of a hypotenuse, which is negative y, and the cosine of theta, which is adjacent of a hypotenuse, and you can see the adjacent side to the angle is just positive x over 1, which remains as such. While the tangent of theta is opposite over adjacent, which is negative y over x, and that is it. So in all cases, you can now see in that quadrant, the cosine is positive. This cosine is the one which is positive in that quadrant. You saw that in the first quadrant, all of them are positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive. And in the fourth quadrant, the cosine is positive. So we can easily talk about that is now the introduction, and for you to easily remember what we have just said. The first quadrant is represented by A. The second quadrant is represented by S. The third quadrant is represented by T, where tangent is positive. Here the cosine is positive. All of them positive. Here the sine is positive. And to remember that, you can easily say, add sugar to coffee, or ask Simon to come. If you would speak like a science teacher, you would say, all science teachers complain. But that is just a way of making you remember how the quadrants are behaving. That is a simple introduction of trigonometry. The keyword is SOHCAHTOA. Please remember, you will be able now to use this one as we move forward. Thank you, and let us meet in the next video.